Good day, everyone. Today, we will present a video roleplay about gene therapy and its effects on science, ethics, and society. Our case is about a 10-year-old boy named Liam who has a rare genetic disease that weakens his muscle. Doctor says gene therapy may help him, but treatment also has risk and is very expensive.
So, what exactly is gene therapy? First, let's start with the basics. This is a gene. Genes are made up of DNA, which are the blueprints to build the enzymes or proteins that do the work for your body. As far as we know, humans have between 20,000 and 25,000 genes, and most people have 2 copies of each gene inherited from each of our parents. They are the building blocks of our physical makeup, from the color of our hair, to our athletic abilities, to our immune system. But sometimes genes aren't built correctly, and a small adjustment to the DNA within our genes can change how our proteins work, which can affect how we breathe, walk, or digest food properly. To better understand how genes change, here's Dr. Michelle Kalos.
So our genes are mutating all the time as a result of chemical processes in the cell, as well as external influences like ultraviolet light. We can also inherit mutations from our parents. Now, when we wind up with these mutations, they can sometimes cause disease, and that's really where gene therapy comes in.
If genes are like the blueprint to our body, gene therapy can fill in some missing drawings. Gene therapy is the introduction, removal, or change in genetic material, specifically DNA or its molecule cousin, RNA, into the cells of a patient to repair or change a gene to treat a specific disease. The transferred genetic material then changes how a protein, or group of proteins, is produced by the cell. It can reduce levels of certain disease-causing proteins, increase production of disease-fighting proteins, or even produce new or modified proteins within the cell. You may be curious how a gene and the genetic material it holds is transferred to the cell during gene therapy. Well, a gene cannot be directly inserted into a cell. Instead, a carrier, also known as a vector, helps deliver the gene. Typically, viruses are used as vectors because they've evolved to be very good at sneaking into and infecting cells. But in this case, their motive is to insert the gene, or genes, into the cell. The infectious part of a virus is removed, allowing it to still enter the cell's nucleus without making the patient sick. It's worth noting there are 2 kinds of gene therapy, in vivo and ex vivo.
In vivo gene therapy, the genes are introduced directly into the patient's cells while the cells are still in the patient's body. In ex vivo gene therapy, cells are removed from the patient's body, then the genes are added to those cells in the lab, and the cells are then returned to the patient. The right approach depends on the disease that the patient has and the tissue that's affected, and that would tell us which is the best way to approach this.
Advances in gene therapy research allow us to treat and hopefully someday avoid rare and debilitating diseases. For more information and resources about gene therapy and how it works, go to asgct.org.
So, the question is, should Liam receive gene therapy? Let us hear the different perspectives.
As a scientist, gene therapy is a medical treatment that changes and replaces damaged genes inside the body. So in Liam's case, doctors can insert a healthy gene into his cells to help his muscles function properly. Okay, these treatments gives hope to patients with genetic diseases because it targets the root cause of the illness. Benefits include better life quality, reduced symptoms, and possible long-term improvements. However, there are risks such as side effects, immune reactions, and unknown long-term effects. So even though it is still developing, gene therapy is considered a major breakthrough in medicine. As Liam's doctor, my priority is his safety and health. Traditional treatment are no longer enough for his condition. Gene therapy may help his properly, gene therapy may offer Liam a better future.
As Liam's parent, this is very difficult for our family. Every day I see my child suffer because of this disease. It's hard to watch him struggle while knowing there may be a treatment that could be helping him. When I heard about the gene therapy, I felt hopeful. Maybe my child finally be a normal. But I also afraid, what if the treatment fail? What if there is a dangerous side effect? What if we spend our savings and still doesn't not work? Even with this fear, I want to fight for my child's future.
Gene therapy may also save lives, but it also raises ethical issues. One major issue is fairness. If only rich families can afford gene therapy, then poor families may not get equal opportunities for treatment. Another issue is consent. Liam is only a child, so adults must make careful and responsible for decisions. Yet, we must think about the future effects of changing human genes and how society may misuse this technology. Science should help people, but it must also follow moral values and responsibility.
The government plays an important role in protecting public welfare and ensuring medical safety. Gene therapy should not be freely used without rules and regulation. We must also think about accessibility. If gene therapy is not available on rich families, inequality in healthcare may become worse. That is why government should not support healthcare programs and financial assistance for patients who truly need treatment.
So, gene therapy offers hope for patients with serious diseases.
But ethical concerns and fairness must also be considered.
Patient safety should always come first. I understand the risk, but I want to give my child a second chance.
That's why strict regulation and government is important.
After discussing different perspectives, the group reached a final decision. The group decided on a conditional yes. Liam may receive gene therapy if doctors approve the treatment, parents provide informed consent, government regulations are followed, continuous monitoring is provided. The group believed that gene therapy should be used responsibly and ethically.
Our group recommends strictly laws and ethical guidelines for gene therapy. Number 2, proper medical monitoring. Number 3, financial support for patients. Number 4, continued scientific research. Number 5, equal healthcare access for all families.
Gene therapy offers hope for curing genetic diseases, but it also creates ethical and social challenges. Science, healthcare, ethics, and government must work together to ensure this technology benefits societal safety and fairly.